returned. Happy New Year. It's the first day of the year. I'm back. I'm back to hear that song that I had in the last stream. Is it copywritten? I have no idea. Anyway, I should review to make sure my mic's actually good. Let's see. Alrighty, looks like I'm still hearable. Decent. Alright. So over here. Why are the arms not? Did I not have the arms? No, they should be in the stair system. There, yeah. Where's the part studio for that? There it is, top and bottom. Okay, so let me come in here and give these materials. We're looking for oh, it's PLA, but I don't think PLA's here. ABS, acrylic, nylon. High density glass. How about polycarbonate plastic? I'll just assume that's what we'll. What is PLA made of? So it's a thermoplastic similar to polypropylene and polyethylene. And what did I give this thing again? Added material, polycarbonate. Alright, how about PLA density? Hopefully the AI is right. What are we looking at here? Okie dokie. Not even gonna lie to you. How that translates. Okay, so pound/millimeter. I'm lost. Alright, help me please. Oh wait. Name. Density. What is this? Modulus. Tensile yield strength. Compressive yield strength. Ultimate compressive. Well, I don't really have the ability to test that. I don't have a stretcher or a crusher, so let's just, alright, let's look at PLA. Alright, PLA's that. Is PLA polycarbonate. No, PLA and are not the same material. PC, what the heck? Oh, polycarbonate. Oh, polylactic acid. Okay. Oh. Well then. Okay. So it's polylactic acid. So let's see if we have polylactic acid as a choice. So poly. Alright. Polycarbonate. Ah, man. Okay. So it's not polycarbonate. That's polylactic acid. Not polyurethane, but man, I don't even know. I don't know what to do. I really want to go through the effort of trying to figure out all those things. Maybe I should use polycarbonate. Well, anyway. How about polyethylene? There we go. Okay, similar. PLA is okay. Has similar characteristics to polypropylene, polyethylene, and poly. Alright, so maybe I'll just run with polyethylene. Wait, it's ethylene, this is not ethylene. Looks like the closest I have is polypropylene. Yeah. So polypropylene it is. Can I do any more? No properties. This music's pretty nice. think this has any kind of element analysis, right? On shape simulation. Let's go to the next page. Alright. Let's see this. Adding load, running. Should I do this? What does this even look like? Yeah. I straight don't know this, so me doing this, I'm gonna be cooked. Alright, on shape simulation is easy, fast, accurate. Oh, this is transcript. What am I doing? Future is dead. Not this time, buddy.
On-shape simulation is fast, easy, accurate, and meaningful for agile product design decisions. This toolset allows you to simultaneously design and analyze assemblies in Onshape's secure cloud workspace with unified CAD, FEA, and PDM capabilities. Onshape's unique approach to simulation introduces a dramatically simplified workflow. This allows designers, regardless of expertise, to receive mechanical guidance with reasonable and robust FEA results as frequently as needed throughout the product development process.
I might be cooked.
Simulation uses powerful secure cloud computing for fast and interactive FEA results. This removes the heavy lifting from your computer hardware so you can focus on your designs. Explore how design variations affect simulation results quickly without having to worry about time to process new results. When you modify the CAD model, the simulation results refresh automatically. Onshape simulation is built into Onshape, making use of Onshape features and techniques you already know: configurations, variables, document history, versions, and branching and merging. Securely share FEA results with other Onshape users when sharing the Onshape document. Simulation is available to professional and enterprise Onshape users.
Alright, that makes sense.
This course dives into using Onshape simulation to evaluate linear static loads on
Free
assemblies.
CAD, here I come. I
Learn
might still
how to
watch the
use or
tutorial.
modify the assembly conditions already defined. Add a load and evaluate the results. This course also explores creating multiple simulations, sharing results, and collaborating within simulations.
Do I want to do the lesson right now? I don't know. I think I just want to. How about I just get the weight from my stuff right now? Area. Give me the weight. Alright, mass. Alright, you know what? I don't know why I thought it would be in grams, not in pounds. Maybe I should switch. How do we do that? Workspace units. Yep, thank you. Alright, an understandable unit. 13.2. Alright. You know what? All I really need to do is just make this thing thicker. But I can also, I don't know. Let's see. So let's go back to the steering one. Currently, when I set this down, these bend up. But in all honesty, that's probably because it's only half the strength, because it's supposed to be the front, the bottom, and the top, not the bottom holding all the weight. No, I seriously doubt the top's going to be strong enough to hold it in place. Also, when it turns on, this does not stay where it's supposed to be and instead goes sideways. Oh man. Let's look at what he did. Oh wait, I think I see the problem. I should be fastening so that this doesn't become another spinning area. This should be bolted, not with a loose pin. That way that when it does turn, it'll push and not spin. Okay. Well, what do I do here with that information? Can't really do anything. It's to my knowledge. Alrighty, well. Damn. I'm really stumped. Let's watch this stuff.
The simulation user interface has
When this
three
video's
major
over, I'm
components:
out.
Simulation load tools, simulation field, and simulation panel. While adding a simulation occurs in the assembly, the process to set up a simulation starts in the Part Studio. In the Part Studio, begin with assigning materials to all instances. Simulation requires a material for all non-fixed components, including standard content. Next, create components that will act as fixtures in the assembly. Only one fixed component is required, but some simulation setups will utilize multiple. Maintain a realistic assembly and eliminate abstractions to optimize for fast, accurate simulations. Once the Part Studio has appropriate materials and fixtures, create the assembly. In the assembly, fix the fixtures and then define the degrees of freedom in the assembly with mates. Groups can be used to fuse parts together and are valid simulation connections. The tangent mate, pin slot mate, parallel mate and relations are not supported for simulation. With an assembly that has unsupported mates, move those mates into the correct position, suppress the mate, and then utilize the connectivity method mates and touching faces to bond the faces for the simulation. With materials, mates, and at least one fixed component, the setup is complete for creating a simulation. Let's take a look at the simulation panel and the simulation load tools. The simulation panel is located on the right of the assembly tab. Select the simulation panel to expand it. Without any simulations created yet, the panel shows simulation settings and the Add Simulation button. The simulation settings are discussed in depth in a future video. Here, a simulation is added prior to creating loads if desired. Alternatively, adding the first load to the assembly automatically creates the first simulation. Utilize named positions to orient the assembly with preferred positioning for a desired load. Consider the unconstrained degree of freedom of the assembly and its mates. In order to fully constrain a position, an additional or more restrictive mate may be required, an additional part might need to be fixed, or the simulation method in the simulation panel settings might need to be changed to satisfy the physical realities of the assembly construction. For example, this assembly has a second fixed component to ensure a static assembly for running the simulation. In the assembly toolbar, there are 5 available loads: force, moment, bearing, pressure, and acceleration. These loads will be discussed in depth in future videos. Now that the first load has been added to the assembly, the first simulation is created. In the simulation panel, a simulation table now exists, and the Add Simulation option is moved to the bottom of the panel. The simulation table has all simulations listed for this assembly. Modify the magnitude of loads and enable or disable multiple loads per simulation from this table. When multiple simulations exist, right-clicking on a simulation column header that is not active allows you to set that simulation to be active. Additionally, a simulation field now exists above the instance list. Here, a drop-down list of all existing simulations are available, providing another method for changing the active simulation. The status of the simulation is displayed, and the ability to show results is provided within the simulation field. Let's enable Show Results to run the simulation. Utilize the simulation settings in the simulation panel to change the color legend and connectivity method. Show connections to visualize the connectivity method applied. The status, results, and simulation settings are discussed in depth in future videos. Because on-shape simulation truly is on-shape, the simulation workflow is as flexible and robust as any other on-shape process. This includes the ability for a single user to have multiple tabs open, working in the Part Studio while the assembly keeps pace with changes as Show Results is enabled. Branching workspaces and creating configurations also provide unique benefits for evaluating designs with simulations. Branch workspaces to evaluate design changes, carrying your simulation setup into each branch. Take advantage of OnShape's selective merge feature to merge design aspects from one branch into another. Configure a design to test different product options to evaluate how different instance size or thickness alters the results of the simulation. Note that simulation loads are not configurable in the configuration panel.
Most fun
They
tutorial
can
ever.
only
I'm
be
putting
edited
my
in the
own
simulation
music.
panel or in the instance list. This video discussed the simulation workflow and user interface. Next, we will cover the process of setting up a simulation.
Alright, with that said, setting up a simulation, huh? My mind is completely out of it. I didn't think they had on the top one. I'm gonna do that, see how it looks. If not, then I'll probably just add another millimeter to this, and that should make it stronger. Like I said, it has stiffness. I won't be able to do material analysis, but you know what? I probably don't need to. Yeah. With that said, Happy New Year. New year. Car needs to get finished this year, please.